In this video, we will work through a few examples. The basic terminology of trigonometry at GCSE level was explained in my other video called SOHCAHTOA Explained. So make sure you watch that one first if you're not sure about the terminology used here. If you find this video useful, please give me a like and subscribe. Also, feel free to comment below for any questions or any other topics so that I could make more videos you would benefit from. Let's get started. Question 1. Calculate the length AB. First, we need to locate length AB, which is here. Value given 15 centimeters is the hypotenuse. It's the longest side of the right angle triangle, also the side opposite 90 degrees. Angle of interest is the 42 degrees. For 42 degrees, my length AB is the adjacent side. So we have A and H, therefore we're using cosine equals adjacent over hypotenuse. Substitute into the value. Cosine 42 degrees equals AB over 15. We're looking for AB, which is the adjacent. So if you look for the triangle A, adjacent, my cosine and hypotenuse is on the same level, therefore it's a multiplication. So length AB equals 15 times cos 42. Put in the calculator, we have 11.147 centimeters with 3 decimal places. Question 2. Work out the value of x is here. So firstly, knowing what we're looking for, and then what is that? Is the hypotenuse of this right angle triangle. It's opposite 90 degrees and also the longest side. Angle of interest 35 degrees. For 35 degrees, 20 centimeters is the opposite side. So we have O and H. Therefore, using sine equals opposite over hypotenuse. Substitute into the value. Sine 35 equals 20 over x. Hypotenuse is what we're looking for. So to look for hypotenuse, we have opposite over sine. Therefore, x equals 20 over sine 35 degrees, 34.869 centimeters, 3 decimal places. Question 3. Work out the value of x. Here's our x. Hypotenuse is the length over here, opposite 90 degrees, longest side. Angle of interest, 42 degrees. For 42 degrees, my length x we're looking for is the opposite side. Our length 11 centimeters is the adjacent side. So we don't need hypotenuse to set up our equation. We got A, O and the angle. So TOA, tan equals opposite over adjacent. Substitute the value. Tan 42 degrees equals x over 11. X opposite is on the top, so tan and A same level, multiplication. X equals 11 times tan 42, give me 9.904 from the calculator, 3 decimal places. Question 4. Calculate the sides of angle ACB. So it's that one here. Mark it with a question mark. Hypotenuse is 16 millimeters, opposite 90 degrees, longest side. Angle of interest, angle C. For angle C, 5 millimeters is the opposite side. So we have O and H, therefore we're using sine. Sine equals opposite over hypotenuse. Substitute the value sine C equals 5/16. Looking for angle, we will need to use the inverse sign. Therefore, C equals sine -1, 5/16. Put in the calculator, we have 18.210 degrees with 3 decimal places. Question 5. Work out the value of x. Again, that's an angle. 24 centimeters is the hypotenuse, opposite 90 degrees, longest side. Angle of interest, x. For x, 16 is the adjacent, so we have A and H and the angle, so we have to use cosine. Cosine equals adjacent over hypotenuse. Substitute the value, cos x equals 16/24. Using the inverse cos, x equals cos -1, 16/24 equals 48.190, 3 decimal places. Question 6. Calculate the size of angle BAC. So angle A is here, BAC, BAC. So that's what we're looking for. Hypotenuse is length AC, longest side, opposite 90 degrees. Angle of interest, angle A. For angle A, 9 centimeters is the opposite side, 5 centimeters is the adjacent side. So we don't need hypotenuse in this formula. We need A and O because that's where the known values are. So we're using TOA, tan equals opposite over adjacent. Substitute the value, tan A equals 9/5. Work out angle A using inverse trick. A equals tan -1, 9/5. Put in the calculator, 60.945 degrees. Last one, question 7. Work out the size of angle BCD. So BCD, that angle here. This looks very different from what we've done previously, but the only difference is instead of having one right angle triangles, you're having two. You have one on the left hand side, right angle triangle, and one on the right hand side, right angle triangle. So angle C is what we're looking for, so let's look at what values we were given. 9 centimeters. For angle C, 9 centimeters is the opposite side. Side CD is the adjacent. CD or DC makes no difference, it's the adjacent side of angle C. Hypotenuse is side BC. We know nothing about the hypotenuse, so we're not gonna using that value. The adjacent side, DC, is the adjacent of angle C, also part of the value given, 22 centimeters, so we may have a chance there. On the left hand side, we have 37 degrees given. For 37 degrees, 9 centimeters is also the opposite side. Side AD, the other part of my 22 centimeters, is the adjacent of 37 degrees. So we're using the formula with O and A, opposite and adjacent. So we have TOA. Triangle ABD on the left hand side. We have tan 37 degrees equals 9 over length AD. Rearrange the equation, we have AD equals 9 over tan 37 equals 11.943 centimeters. So I can put the value here. Then from 22, I can work out the length DC by using subtraction. So now we have 10.057 for length DC. Then we look at the triangle on the right hand side, BCD. Again, we're using TOA. Tan C equals 9 over 10.057. Using inverse tan to work out the angle C, we have 41.825 degrees, 3 decimal places. So here you go, we have just worked through 7 examples. If you're still with me, click like and also subscribe to my channel. Comment with questions that I might be able to help you with in future videos. Thank you for watching and bye for now.